Okay, let's say you need to make a carbonate buffer of pH of 12. How many grams do you need of sodium carbonate must you add to 2 liter of 0.2 molar of sodium bicarbonate to make the buffer? So let's write what we have down. So we have sodium bicarbonate, which in this case it's a base, and we have sodium carbonate, which is an acid. So the conjugate acid for sodium bicarbonate is HCO3 minus, and the conjugate base for sodium carbonate is CO3 2 minus. So we are given the information on sodium bicarbonate, so which means we are also given the information on this acid. So we have the volume, which is 2 liter, and we also have the concentration, which is 0.2 molar, and we also have the Ka, which is 4.7 multiplied by 10 to the power of negative 11. So we need to find the mass of sodium carbonate, which we must add to this amount of sodium bicarbonate. Yeah, and we are also given the pH and Ka. So what we have to do now is to find the ratio of the concentration of these two that will give us a pH of 12. And how do we do that? Well, we have this equation which we use to do that. So we have pH is equal to pKa plus the log of the ratio of the concentration of the base over the concentration of the acid, so which is over the concentration of the acid. Now we want the ratio of this ratio that gives us the pH of 12. So we can just take that 12 and plug it into our equation. So we have 12 is equal to pKa plus the log of that ratio, CO3 2 minus, divided by the concentration of the acid. Now from this equation there's something missing for us to find that that ratio. So pKa is missing, so we can find pKa since we are given the Ka. So to find pKa, the pKa is equal to the negative log of Ka, and that gives us negative log of pKa, which is 4.7 times 10 to the power of negative 11, and that gives us a value of 10.33. And then we can plug it into that equation and solve for that ratio. So we have 12 is equal to 10.33 plus log of the concentration of the base over the concentration of the acid. So we can take that to the other side, and then we get 12 minus 10.33, we get 1.67 is equal to the log of the concentration of the base over the concentration of the acid. So to get that ratio, we can just do this. So we have the concentration of the base here and the concentration of the acid is equal to 10 to the power of negative 1.67, and that gives us a value of 0.0214. So that is the ratio that we were looking for. So remember, this ratio basically means that for every 1 molar of the acid, we have 0.0214 molar of the base. So this is the acid and this is the base. So now that we have what we were looking for, the ratio, we can go back to the question and look and check what we were looking for. So we were looking for the mass of sodium carbonate that we must add to this amount of sodium bicarbonate. So we're given the volume and concentration. From these two, we can find the number of moles of the acid. So finding the number of moles of the acid, so we have number of moles of the acid is equal to the concentration of sodium bicarbonate, so which is 0.2 mole HCO3 divided by 1 liter, multiply that by the given volume, so we have 2 liter. So this will go out, this will go out, and now we have the number of moles of the acid, which is 0.4 mole of HCO3 minus. So now that we have the number of moles of the acid, we can find the number of moles of the base and then find the mass that is needed to be added. So we can find the number of moles of the base now. So we have the number of moles of the base, which is CO3 2 minus, is equal to the number of moles of the acid, 0.4 mole of the acid, multiply that by the ratio, which is 0.0214, let's say, mole of the base divided by 1 mole of the acid. And that gives us, let's say, this one goes out, this one goes out, and then now we have now we have 0.0085, no, let's say 86, which is equivalent to 8.6 multiplied by 10 to the power of negative 3, say mole of the base. Now that we have the number of moles of the base, we can find the mass that is needed to be added. So the mass of sodium carbonate is equal to 8.6 multiplied by 10 to the power of negative 3 mole of sodium carbonate. Multiply that by the molar mass of sodium carbonate, which is 106 grams of sodium bicarbonate, divided by 1 mole of sodium carbonate. And this goes out and this goes out, and we end up with 0.91 grams of sodium carbonate. And that is your final answer.